In this segment, we're going to go over the large-scale structure of the universe. The large-scale structure is the distribution of galaxy clusters and superclusters in walls and filaments which surround voids. And voids are mostly empty of galaxies. So the largest structures in the universe are walls, filaments, and voids. Let's look at each one of these individually. Walls are areas containing many galaxies and galaxy clusters. The key word here is areas. Walls are areas containing many galaxies and galaxy clusters. Filaments, in terms of the large-scale structure of the universe, are linear regions containing many galaxies and galaxy clusters. The key word here is linear, or a line. Voids are regions containing relatively few galaxies. The key word here is regions. Now the sky is filled with galaxies and clusters of galaxies. Galaxies are observed in clusters ranging from just a few galaxies in a cluster to thousands of galaxies in a cluster. And those clusters appear to be grouped into larger superclusters. In this image from your textbook, we're looking at 3 different constellations: the constellation Leo, the constellation Bootes, and the constellation Virgo. So if you look very carefully, right around in the center, we see the Great Virgo cluster. It's located near the constellation Virgo, and it's a bright grouping of white, very bright galaxies, and so it's a cluster of galaxies. So we call it the Virgo cluster. There is more than 1,000 galaxies in that greenish teal area that I circled. Another cluster in this picture, in this image, is the Coma cluster, and it's just above the Virgo cluster. Now the Virgo cluster is linked with other clusters in our own supercluster, our local supercluster. So the Virgo cluster is linked with other clusters to form our supercluster called the local supercluster. So clusters link together to form superclusters. The name of our supercluster is called the local supercluster, and is roughly a disc-shaped swarm of galaxies and galaxy clusters, and it's about 50 to 75 megaparsecs in diameter. Now, superclusters are not scattered at random throughout the universe. They are distributed in long, narrow filaments of galaxies and in thin walls that outline great voids. Let's enlarge this drawing from your textbook. Now in this diagram, Earth is located here in the center. We've done enough observations to the right and to the left, and we have an idea of what the structure looks like of the universe. The nearest galaxies are in this red color. More distant galaxies are in green, and the very furthest galaxies are in the color blue. The distance to these very furthest galaxies is about 3 billion light years. Now if you look closely, you'll see these lines, these linear lines. These linear lines are filaments. Filaments are linear regions containing many galaxies and many galaxy clusters. So the superclusters are connected by these filaments. Now we also see this very, very large structure, and that's called a wall. And the name of this wall is called the Sloan Great Wall. Now the Sloan Great Wall was discovered by the Sloan Digital Sky Survey and is almost 1.4 billion years long, billion light years long. It is the largest structure known in the universe. Now remember, a wall is an area connecting galaxies to clusters of galaxies. Superclusters are connected in this great wall. Now, walls and filaments outline voids. Now, this astronomy picture of the day from 2007, specifically August 27th in 2007, is showing a great void. This is an artist's depiction of a huge cosmic void. So from an analysis of this cosmic microwave background map, is that this void is imprinted in the map. And so in our 3D structure of the universe, there seems to be this large void in our universe. Now remember, a void is a region of volume and space that is lacking galaxies and clusters of galaxies and superclusters. An analogy to think of how the large-scale structures of the universe look like is the soap bubble theory. Now imagine you fill your sink with water and you put soap in it, and you generate soap bubbles. Well, inside a bubble is virtually nothing, so that would be the void. The 3D surface of the bubble would be the wall. Remember, wall is an area, so it's the surface of the bubble. And where the bubbles meet, they form a line, and those lines are what we call filaments. And so this analogy should give you an idea of what the large-scale structures look like in our three-dimensional universe.